This is Newton's Cradle, a simple yet satisfying desk toy. This is the sport of billiards, a fun game that many people enjoy. What do these two things have in common? Well, that is their use of the conservation of momentum. In this video, we'll be talking about what is the conservation of momentum. But first, we must ask ourselves, what exactly is momentum? Momentum, according to the dictionary, is the quantity of motion of a moving body measured as a product of its mass and velocity. To put it in a layman's terms, momentum is the motion of an object with mass. It is harder to change the motion of an object with more momentum. For example, it is harder to stop a train than it is to stop a bicycle. This is because the train has a lot more mass and is also traveling faster, so it has a greater velocity. And the bicycle has much less mass and velocity. When talking about momentum, teachers at schools and educators would also always refer to the equation P is equal to V times M. Now, what does this mean? I'm going to put this in a box here so we can see what we're referring to. So we have to understand that P is always momentum. So momentum, P, is equal to velocity V times mass, which is obviously M. To break these down into simpler terms, momentum is understood, the measurement, the unit for momentum is kilograms per meters per second. You can take this out. I usually like using brackets outside because it makes things more segregated, more understandable for me, but this is how you usually express momentum. Velocity is expressed as meters per second, and mass is expressed for momentum, kilograms. You can see that if we break down the unit for momentum, kilograms comes from the mass, and meters per second comes from velocity. Put these together, we get kilograms meters per second. Let's look at an example. Here we have a bowling ball. The bowling ball's weight is 5 kilograms. We have 3 pins here. In bowling, the bowling ball is hurled towards the pins. For the sake of simplicity, let's say that the velocity of the bowling ball is 5 meters per second. When calculating momentum, we need to make sure that our mass is in kilograms and our velocity is in meters per second, thus giving us momentum in kilograms meters per second. Now let's calculate the momentum of the bowling ball while traveling to the pins. P, momentum, P is equal to mass times velocity. We can get our mass here and our velocity here. P is equal to 5 kg, kilograms, times 5 meters per second That means our velocity is 25 kilograms meters per second. Now we can ask ourselves the video-old question: what is the conservation of momentum? Well, let's break down the name. First, we studied what momentum is. Momentum is the product of mass and motion. So, mass times velocity. Now let's look at conservation. Conservation has the root word conserve if we just add a little e. So if we write here conserve, we get, and put these two together, we get conserve mass times motion. Then if we break this down even more, mass in motion, we get from mass times motion. And we put this in the present verb tense, conserving. And then put this together. That's the definition of the conservation of momentum. The conservation of momentum is conserving mass in motion. Ladies and gentlemen, today we studied the conservation of momentum. We've broken down the wording, the conservation of momentum, learned what momentum is, and what it means to conserve momentum. We also put these into examples and understood it fully, so that we can apply them in the future. I hope you enjoyed this video as much as I did making it, and I hope you have a great day. Bye now.